Hi, this is Steve Michelotti of the Azure Government Engineering team. I'm joined here today by my colleague, Yujin Hong, also on the Azure Government Engineering team. Welcome, Yujin.
Hi, Steve.
So as we get into this topic, we're going to talk about serverless on Azure Government. You and I have had a lot of discussions in the office about this topic. We've talked about, what is serverless and how can we communicate this to our customers and all the different options we have on the Azure platform. So we thought it'd be good to just come in here and have a discussion about it today to go through all the options.
Right, yeah, totally agree.
Okay, so as we get into it, I think the thing we've talked about a lot, just again, these side conversations in the office are how do we describe the evolution, so to speak, of serverless and how did we get here?
Right. So I think as developers, we've seen this transition from building everything on-prem and having to worry about all these things yourself and then starting to deploy things to the cloud. And now there's serverless, and that's another level of abstraction.
Right, yeah. Especially when we start getting these buzzwords like serverless. What the heck does that mean? So hopefully we can clear some of that up as well. So let's talk about that. So you just mentioned on-prem, going all the way from on-prem. So when I think about my crusty on-prem days, going back in the day where we did everything on-prem, right, we had a lot of things to worry about. So if we look at just all the questions we have on this slide, these are things we had to think about, like who has physical access to the servers?
Right.
What do we do if there's a hardware failure or a power failure? And then that's in addition to all the concerns we have about our actual code and scaling the app and that sort of thing. So as we go from the on-prem world to the cloud world, what a lot of times we see is that first step is just a lift and shift to IaaS.
Right.
So when we get to that lift and shift to IaaS, actually things get a lot better. It's not necessarily that technologically innovative, but actually things get better. And we think about that mess of questions,
right,
the questions get smaller. So you no longer see the questions there like who has physical access to the servers. There's no physical servers that you have to worry about. There's no power failures and hardware you have to worry about. Microsoft will worry about that, your cloud provider. But there are still other questions you do have to worry about. These are things like how often do I patch my servers? Mm-hmm. How do I back up my servers? And again, that's still in addition to the code we write as developers, which of course we have to worry about.
And you still have to worry about how many servers you need and how you can actually scale your application.
Exactly. So what we often see is that trend where someone first comes on, they're IaaS, and then they start realizing, let me get more of these benefits by going PaaS. So if we keep walking down that evolution, now when we're in the PaaS world, we eliminate even more questions. And so these questions like how often do I patch my servers, those are gone. I don't have to worry about those anymore. Microsoft will worry about patching my servers and backing things up and managing it. So in the PaaS world, things are looking actually pretty good here, I think.
Yeah.
And if we look at the questions we're asking, we're still asking a few. And these questions usually go around, well, how big are the servers I'm using? How do I scale them up and down and that sort of thing?
But all the other questions before that,
yeah,
the actual servers and the infrastructure, that's all disappeared.
Exactly. So this is why I really love PaaS, because we can get down to this kind of level. But even as we look here, this is where the idea of serverless comes in, because when we look at the PaaS world, so to speak, we are still asking questions about servers. What are the right size server? How can I increase my server utilization? We put the word server here in bold.
Right.
And so this is where serverless comes in. So when people say, what is serverless? The reality is, yes, we still have servers. So serverless doesn't mean there's no servers.
Right.
What it means is we're abstracting away the concept of servers from you, the developer. And so if we go that one extra step here to serverless, it's that serverless is going to take care of, don't worry about what size server you're on or how many instances scaling up and down. The underlying infrastructure will do that for you. And then the only question you have left is how to architect your app. And as developers, technical people like us, that's the question we want to focus on. I don't want to focus on updating and patching my operating system.
Right.
Okay, so this is the evolution of how we got to the serverless. So now if we get real specific here in terms of what serverless options we have on Azure, and specifically in Azure Government, we have three that we'll focus on here. One is Azure Functions, and we'll have you show a demo of that in a second. And then the next one will be Azure Event Grid. We'll talk about that. And then we'll finish up with Azure Logic Apps. So you hear these three things. These are three of our serverless technologies. We have a couple others too, but these are the three that are really our core serverless technologies. So with that, let's sort of focus on each one of these in turn, starting with Azure Functions.
Right, so Azure Functions is basically one of our core serverless offerings, and it basically allows you to run pieces of code that accomplish exactly what you want. And you don't have to worry about the application or any of the infrastructure. As we kind of talked about before, we're kind of taking away that concept of servers away from the developer. So some of the things that come with functions is events, so you can react to specific things. So like if you're putting something on a queue or if you're adding something to a storage blob, these things can be triggering, the functions can be triggered by these sort of events. And then there's different kind of runtimes supported in Azure Functions, so you can author in C# or Node or Java. And then there's all these outputs. So you can kind of send the results of your functions. So there's output bindings. So the same way that our functions are triggered by things, we can also write to other Azure services.
Okay, so it's really a focus on code. So as a web developer, it's not that I have this whole web application that I need to deploy to a server. It's that, hey, maybe I just have a little snippet of code. It might be a single method. And I just want to deploy this section of code up to the cloud somewhere and let Microsoft worry about it for me.
Exactly.
Got it. Okay.
So now let's actually move to a very simple little demo. So basically we have a very simple web application, and it's going to send a message to a storage queue. And we are going to have a function that's going to be listening to that queue for any sort of change or if a message is being written to it. And that will trigger the function, and it will run, and it will output something.
Okay, sounds good.
All right.
Let's get into the demo.
So we've navigated to the Azure Government portal, and here I've actually clicked into my function application, so we can see I already have some deployed. So I want to actually click on New Function, and here we can see that there are all of these different triggers that we can integrate into our function. So there's things like an HTTP trigger or a timer trigger, so you want a function to run on a specific schedule.
Okay, so we have all these different triggers set up, and it's like I could, again, thinking back to my on-prem days, I could write a bunch of code to host maybe a console app that watches a queue of some kind. But boy, that's a lot of infrastructure code I have to deal with and monitor and maintain. Now I can just say, what are the different triggers I have available to me here? Exactly.
So there's like service bus, you can watch the blob storage, like I said. You also have an event hub trigger and a Cosmos database trigger, which, that's a very common use case if you have a database and you want to see the different kind of changes going on there.
Okay, cool.
So we're actually going to create the Azure Queue Storage trigger.
Right.
So let's actually just click on that. And here we can see we have the name of the trigger. And a really cool thing is we can actually directly connect this function to a queue that we have in our Azure storage account. So we just specify what storage account we want, and we can type in the queue name that we want this function to be watching, and then we just click Create.
Wow, okay, so that's pretty simple. We just say, this is the queue I want to watch, here's my trigger, now go write some code.
Exactly,
and
so
there's some code.
All of that integration code you're talking about and specifying which queue you want to watch, all of that we just did a little click through, and we were able to hook our function up to that.
Okay, great.
So let's click on Run just to make sure we have our logs started. So we can see this is just a test, it's a sample queue data, so we know our function is running correctly.
Yes, it's monitoring the queue.
Yes. So let's actually navigate.
Yep, perfect.
All right. So I've opened up my Visual Studio, and this is just a very simple .NET Core web application. And if we look at this index method here, we can see on line 31, we have this queue client. And this queue client is actually connected to that same storage queue that we connected our function to.
All right, so when I saw you do that web app alert queue, that's the queue we're talking to.
Exactly,
okay.
Exactly. And then we have this submit message method. So we're basically going to take a user input and send it as a message to that queue.
Okay.
So let's actually open up. So we can see we have that application we were looking at running locally. So we can submit a message. So actually, let's just send a very simple test message.
Okay.
We can click submit. Let's navigate back to we've navigated back to the portal. We can see in our logs that just triggered our function. We can see the data within data. The message, this is a test, that's the exact message that we sent to our queue. Our function detected that and was triggered.
Okay, so with literally one line of code, you are able to use Azure Functions to monitor a queue and respond to events. In this case, someone writing a message to an event queue.
Exactly, and this was just a very simple scenario, but obviously you can integrate functions in your own custom applications or use scenarios and have many different input triggers and output bindings on even just one function.
Awesome. Okay, cool. All right, we've seen a look at Azure Functions. Let's dive ahead to the next serverless technology. Okay, so the next technology we're going to talk about is Azure Event Grid. And I think it's safe to say, based on the discussions you and I have had, that we both agreed that this has had a lot of confusion with some people. And this is a technology we now have on Azure Government. So from a high level, let's just explain what Event Grid is.
Right.
And Event Grid is this central publish subscribe mechanism, or we can respond to events. These events might be things from Azure resources, like a VM was created. Or it might be more of an application-centric operation, like someone put a message on a queue, like we just saw in your web app example.
Right.
And I think what's interesting from a government standpoint is a lot of times in government we think about compliance. And so when you can respond to these operational events, like someone creating a VM, well, did they do that in compliance with your policies? Did anything about the way they provision that? Did everything make sense? So it'd be nice to get these type of alerts for those operational type of activities.
Right.
But in addition to that, the developer scenarios as well. And you can see the publishers like these various things, event hubs, blob storage. The one at the bottom, custom events, is really important because that is what we can use as developers to really do any pub sub scenario we want. And then we have these various event handlers. We just saw you use Azure Functions, but we have other things like Azure Logic Apps as well.
So I think that slide is really really helpful. But when I see things like Event Grid and Event Hubs and Service Bus, and as a developer, they all kind of seem to have similar functionalities. Like, what kind of differences do they really have?
Definitely. I think we agree. This is something that's been very confusing for a lot of developers out there. And we're not doing it intentionally, but there are different reasons why we use different technologies. So if we look right here, we have these various Azure event messaging technologies. And the three I have listed here are Event Grid, Event Hub, and Service Bus. And that's not even to mention the fact that you just use things like an Azure Storage Queue that we just saw you use in your last demo. So even before I talk about the details of each one of these, I think it's important to note the distinction between an event and a message. So an event is something that's really just a lightweight payload. Hey, something happened. It might reference an entity or something like that. You may need to go and retrieve the full message. But an event is just a lightweight payload, whereas a message might be a large payload that we're sending across the wire for some reason. So with Event Grid, we're dealing with events. We want to do reactive programming. Something happened. A VM was provisioned. A state changed in your application in some reason. This is ideal for Event Grid, and we have this very rich publish-subscribe mechanism with which to do it. The second one is Event Hubs.
Okay.
Event Hubs is really there for these high throughput scenarios like big data pipelines or IoT, where you just have massive billions of telemetry events. I don't want to use the word messages. Telemetry events just coming in. You need massive throughput with something like Event Hubs. And go ahead.
Does that mean it's kind of better equipped to deal with kind of that higher payload of data?
Definitely. So that is the sweet spot for Event Hubs. And then you have Service Bus, which is dealing with messages. So you can have these large message payloads if you need it. So whereas Event Grid and Event Hub is really more lightweight event payloads, Service Bus can deal with heavier weight messages. And not only that, it's high value enterprise messaging. High value mean we can't afford to let any messages fall on the ground. We want to have guaranteed delivery. This is important for order processing, financial transactions, that sort of thing.
I see.
So that's why we had these different technologies for different scenarios. Okay. So what I'm going to do here is I'm going to show a little Event Grid demo, and I'm going to pick up where you left off. So here was your demo where you did the web app, went to the storage queue. Now what's interesting here is we glazed over this, but it's really nice that Azure Functions gives you these various triggers like the queue trigger, but the reality is behind the scenes, it was pulling off that magic by doing polling.
Right.
So it was continuously checking, is there something in the queue? Is there something in the queue? And when it found something in the queue, it pulled that data in. And that works well, and it's nice to abstract that away from us as developers. But Event Grid has something slightly different here. I'm going to do the same demo, but I'm going to use Event Grid. This is publish-subscribe model, which means there's no polling. And instead of a pull model, it's going to be a push model. In other words, when the web app writes directly to the Event Grid knows who its subscribers are, and it's automatically going to push instantaneously to those subscribers. So the Azure function will actually have no need to be polling at all. It won't need to use any resources behind the scenes. It will just instantaneously receive the message.
So does that mean that the event grid will have kind of like a lower latency and like it'll be kind of more immediate?
That's exactly right. It'll just, and you can have multiple subscribers. So in this case, in the queuing example you gave, whoever the first person to dequeue that message, they got it, no one else did. But with Event Grid, since it is pub sub, you can have multiple subscribers interested in multiple messages, and it's lower latency because we are immediately pushing those messages out to the interested subscribers. Okay, so with that, let me get into a demo of Event Grid. Okay, here I am back in the Azure Government portal, and I can see that right here is the queue trigger that I just saw you build.
Yep.
And I'm going to add a brand new function here. And instead of like an event grid trigger or any of these other ones, I'm just going to use a straight up HTTP trigger to illustrate that this is really like a webhook type of scenario that we can use it for. So I'm going to call this web app alert func. And just for simplicity, I'm going to use anonymous here, and we're going to create a brand new Azure function. So with your Azure function, you use the queue mechanism for the actual binding. What I'm going to do here is I'm just going to put a snippet of code in. Now, I just put about 30 lines of code in, so let me back up and show exactly what I just put in. So at first thing we have is this if statement on line 15. And this is, when it comes to making a subscription in Event Grid, it has to be a valid URL. And we have to give a mechanism to know not only, yes, am I a real URL, but I know how to process Event Grid messages. And it does this by, it sends us a validation code and we echo the validation code back, which is why you can see us returning it right here. So this if statement is a one-time thing only when we're setting up the subscription. And then after that, if we scroll down a little bit here, we can see that I'm just doing similar to what you did. I'm just logging the message to the logging just to prove that we got the message.
Right.
Okay, so with that, it's time to set up our actual event grid here. So I'm going to flip over to the Azure CLI, and I'm going to put a couple commands in here. So this first command here, I'm doing AZ event grid topic create. We're going to give it the name of our topic. So you had a queue called web app alert. I'm creating an event grid topic called web app alert. I'm putting in US Gov Virginia, and I'm just putting in a resource group called serverless demo. So I'm creating this topic, and this will just take a second to run. Okay, so that topic just got created.
So this topic is kind of like a queue. See that as an endpoint.
In a way, it's like a queue, but it's like a queue on steroids because of things like the fact that we can have multiple subscribers and it can push out instantaneously. So it's actually much more than just a queue. But I think it's good to conceptually think of it like that in many ways. All right, so now that we've created a topic, we want to create a subscription. And so I'm using AZ Event Grid event subscription create, and actually I need an endpoint here. And so what I'm going to do is I'm going to come to this function that I just created, and I'm going to copy the endpoint for this Azure function, because this is the subscription. We say, hey, when someone posts a message to this queue, we want to be able to run this. This is the URL we actually want to be able to invoke. Okay, now actually right here, I did this intentionally because I knew we were going to get an error. I wanted to focus on the fact that we have that validation code, and it's saying I couldn't validate. Well, why not? Well, because I didn't actually run the function. So I'm going to click save and run here. So the function is actually going to be invoked. And then once this runs, we can scroll down a little bit, and let me just clear the console log here so we can see this happens. Now what I'm going to do is I'm going to run this validation one more time. So the validation to create a subscription is going to make sure, does this endpoint exist? I don't want to get a 404. And if it does exist, great. Does it know how to deal with Event Grid? Meaning, if I send you that validation code, do you know how to parse the message and send the validation code back and make that initial handshake? And actually, I can see back here in the window, right here, there's the validation code that it sent. We're echoing it back. Yes, we know how to deal with it. And so we've created the subscription. Okay, so we've created the topic. We've created the subscription. Now it's time for our web app to actually post a message to the Event Hub topic. So in order to do that, we need to get the URL of the Event Grid topic and the key. So what I'm going to do is run a couple more commands. This first command is to get the actual endpoint of the Event Grid topic, and we can see the endpoint right there. And the next one is to get the key. So if we look at this endpoint, this is the endpoint that I need to invoke to actually publish something on the Event Grid topic. And then the key is right here. Now, I'm not concerned about anyone seeing my key because I'm going to delete this resource as soon as this recording is done, so I'm not worried about from a security perspective. Okay, so I'm going to copy this endpoint right here, and I'm going to put it into my web app right here. And then we're going to do the same thing for the key. We're going to copy this right here, and we're going to paste it right in there. Now, what I'm going to do is I have the exact same home controller code. This is on line 31. You have the AppQ client. I'm going to take this away, and I'm going to use the EG client, the Event Grid client, which I have, and I injected this into my controller. And if we look at this, this is just going to, if I go to the definition here, we're going to see that this is literally just making that HTTP request to post something on the Event Grid here. Right. Okay, so here I'm in the controller, the home controller, and I am going to now just run the app, Control F5, and we're going to post a message to this Event Grid topic. So this is my really cool web app alert, and let's submit it. So same exact thing you did. If I come back to the portal here, and I can see right here, this is the message. It was instantaneously submitted, and we can see right here, it says, this message is my really cool web app alert. We can see right here. So on the surface, very similar to what you did, but under the cover, some significant differences occurred, which is the fact that we can have multiple subscribers for our events. It's publish subscribe, so we don't have any latency. We get instantaneous publications. We don't have to do polling, which means we use a lot less resources internally, and I don't have to worry about any of the plumbing. Azure just does the work for me.
That's awesome. All right, so now we are going to move on to our last serverless technology, Logic Apps. So while Functions was kind of about the code itself and running that code, Logic Apps is more about a workflow. So it actually provides a visual design experience for creating serverless workflows without having to write any code. So no matter how complex like this logic can get, you can really utilize all the built-in connectors that Logic Apps provides, and you're able to kind of create that workflow and visualize it right in front of you.
Okay.
Yep. So I'm going to actually now, and like I said, Logic Apps comes with more than 200 connectors, and some of the examples that we can see on here are, the Azure Functions or App Service, Cosmos Database, so some of the core Azure services that you can kind of connect to the same way that we saw in Functions. But however, Logic Apps also provides all of these other kind of connectors for Salesforce or Twitter. You can do it with Office Dynamics 365, Workday. So it kind of provides a better B2B experience, and you can easily integrate with all of these other with all of these other services. Yeah.
I feel like this is a really important point because a lot of times when developers first see Azure Functions and Logic Apps, they think, well, Azure Functions, I can look at a queue and do something. Logic Apps, I can look at a queue and do something. Azure Functions, I can look at Cosmos or a blob and do something. Same with Logic Apps. There's no difference.
Right.
Well, it's when you really start, and in a way that's true. And in those scenarios, that's really your preference. Do you want to write code, or do you want to do drag and drop designers and do what makes you happy and go about your way?
Right.
But when you start looking at all these connectors, this is where Logic Apps really shines.
Right.
You can't do all these different connectors out of the box with Azure Functions.
And you don't have to actually understand how any of them work. You don't have to figure out how to integrate with all these different services and communicate with them and follow their protocols. Azure kind of takes care of all of that for you.
Yes. All right, cool.
All right, so now we are going to move on to the demo. So here I've navigated to the Azure Government portal, and I've actually opened up a Logic app that I've already created.
So already I'm seeing a difference because instead of starting the flow from a queue message, it's starting it from a new Twitter message being posted. That's pretty cool.
Exactly, yeah. And I actually want to go here and click on New Step so we can actually see all of these different triggers that we have available. So if we go to All and we click on Triggers, we can actually see Twitter is one of the most popular triggers. We have Schedule, so you can run your Logic app on a schedule, same way that it's available for Functions as well. There's SharePoint integration. You can also integrate with Office 365. And then some of the actions that are also available, so you can create a blob or create a file, get a message from an Azure queue. So these are all also available in your Logic App workflow. So let me go back up to the top. So like we said, this workflow is actually going to be triggered when a tweet with #Azure is posted. So you see that we have this interval. We can change that interval to however much we like. And this is actually connected directly to my Twitter account.
Okay.
So once someone tweets something with #Azure, the next step is this text translation. So this is actually just pulling from the Cognitive Services API that we have available in Azure. So it's actually sending this tweet text to that API, and it's translating it to English so that we can do more text analytics on the tweet. And this also is from Cognitive Services, but this is the Text Analytics API. So we're going to send that translated text. And if you can see here, that translated text is the output from the step before. So it's kind of showing the workflow. We're taking that output, and then we're sending it to the sentiment analysis. And we're going to get a score from 0 to 1, 0 being negative, 1 being positive. And then the next step is we're also just going to, same API, we're going to extract some key phrases from that tweet for ones that are a little bit on the longer side.
You can really string these together. So I hear a lot of people say, oh, this is writing 0 lines of code. It really, technically that's true, but the reality is you're writing code, but you're writing with pictures instead of text.
Right,
Okay.
exactly. And that is, preference, right? So next, this is a really cool operation. So we saw all of these different APIs that we're pulling from and connecting to, but we also have operations available in Logic Apps, such as for loop or if statements or joins. So these are things you can do in code. And however, Logic Apps kind of allows you to insert these custom pieces of code in here where I'm just joining the key phrases from an array to a string.
Yep.
And then after I have all of these kind of transformations on my data, I want to write it to some sort of data source. So here I'm actually writing it to a Power BI streaming data set. So I have that endpoint, so I was able to specify my workspace, connect to my Power BI account, and then I'm writing the tweet text, the sentiment score we had from before, the location, who it was tweeted by, and then the key phrases. And now when we scroll down here, we can see we have this condition. So like I said before, we can have an if-else statement here. So if we're saying if the sentiment score is less than 0.3, that's kind of negative. We want to be kind of aware of that. We can post a message to a Teams channel.
Okay, so we hope it's all positive, but if it's not, if it's negative,
Right.
we want to know about it so we can address the issue.
Exactly. So now I'm going to actually go to my Power BI account. So this is the streaming data set that we actually saw before. And we can see here, we have the key phrases that we've extracted. We can see the location that the tweets are from, the sentiment score, and then the actual translated tweet text. So things like local testing with live data means faster development with Azure Stream Analytics. We can see most of these tweets are Azure related. So it does a really good job of doing that search.
Great.
So now I'm going to navigate to this dashboard. So we had that streaming data set. We're writing everything to it. I actually built this dashboard from that data set, so it kind of is better to visualize our data, which is one of the perks of using Power BI. So we can see we can have the average sentiment, 0.65. We can see the count of tweet text by location. And then we can see this really cool graph over here. It actually allows us to visualize where these tweets are coming from. And the lighter the color is, it means the lower the sentiment, and the higher means the more positive the sentiment.
Okay, so we can see from the map not only the hotspots, so to speak, but also whether those are positive or negative.
Exactly.
Okay, very cool. And this is all done with just dragging and dropping some shapes in the Logic Apps, connecting them together in the right way, and there's your Power BI dashboard.
Exactly.
Very cool.
Yep.
Okay. All right. So we've talked about a lot of serverless technologies here. We talked about Azure Functions. We talked about Event Grid and Logic Apps. These are all available on Azure Government today. Yes. And I think it really is important to dive into these technologies to understand the strengths and weaknesses of each one so you know what is the right one to use in the right scenario.
Yep. Totally.
All right, cool. All right, this has been Steve Michelotti with Yujin Hong of the Azure Government Engineering team talking about serverless technologies on Azure Government. Thanks for watching.